Today we're going to start a brand new unit. This unit is going to focus mainly on sound and light. I think you're going to find a lot of things you're interested in dealing with sound and light. But first we have to learn a little bit of the basics about oscillations and repetitive motion and the mathematics that goes with it. So today I'd just like to start with a quick rundown of the unit. We're going to start, like I said, with the mathematics of repetitive systems. Then we're going to learn about waves. And then finally, sound and light. Sound and light, again, are our main focus. I want you guys, when we're done this unit, to have a much better understanding of both of those ideas. So we're going to start with the mathematics of repetitive systems with a term that we've already learned this year, and that is the term period, which we saw when we were dealing with circular motion. Hopefully you recall that period measures the time that it takes to complete one full cycle. We did it before with circular motion. Now we're going to do it with all kinds of different motion. So here we have a person as a pendulum, and we'll watch the ball that they're carrying to make it easy to track, and we'll just kind of try and determine their period. So we start by timing their oscillations. There's one full oscillation, there's two oscillations, three oscillations, and finally a fourth. Notice an oscillation is both the forward and backward motion. You must return to the exact same place you started and be moving in the direction of your original motion. So we had 4 oscillations, 4 cycles, and it took 20 seconds. So when we asked for the period would be the time for one oscillation. So we would just do 20 divided by 4, and that would be 5 seconds per oscillation. Oftentimes, we're going to determine the period by looking at graphs. And when we graph repetitive motion, it's going to look something like this. Some of you guys may recognize this as a sine or cosine curve. If you don't recognize it, it's not a big deal. All you have to be able to see is that you're going through repetitive motion. So this would be one full cycle. You'll notice I came right back to where I started, and you can see I'm heading in the same direction I was moving originally. So cycle 1, I'll change colors to make it clear. Cycle 2, cycle 3, and there's no limit to how many cycles you can count. The more cycles you count, the better. So just like we did with the pendulum, I'm going to do 4 complete cycles. This graph doesn't show me any more than 4 complete cycles. So to find the period, I do the time, how much time elapsed, divided by my number of cycles. You can see we had about 3.7 seconds, and we had 4 cycles. When you get the period, the answer is going to be in seconds. Closely related to the term period is the term frequency. Frequency tells you how many times something happens per second. So it is the exact reciprocal of the period. So here we have a glow stick that has LEDs inside that blink. And if we wanted to know the frequency at which they blink, we count the number of times that they blink, and we divide it by the time. Here's what it looks like from the inside. If we take it apart, and you can see we have 3 different LEDs that would blink on and off, and these we want to find the frequency of. And you can see I can change the frequency by hitting a button on this toy. So again, a lot of times we're going to do it from our graph, Just like before, we count our oscillations. It's the same graph, so it's 4 oscillations. But now when we find frequency, the time goes on the bottom and the number of cycles goes up top. So now we have something like 4 cycles, and took 3.7 seconds. Your units will be cycles per second, and that is known as hertz. Okay, in this case would be a little more than one cycle per second, a little more than 1 hertz. Remember, there is a connection between frequency and period. So when we look at these, we saw that period looked like this. We saw frequency look like this. And we can see that the fractions are just flipped. So that means that period is the reciprocal of frequency, and frequency is the reciprocal of period. Remember, period is a capital T because it's a special amount of time, the time for one cycle. Frequency is a small f because capital F is for force. Some quick examples. Okay, so here is an EKG, and if we wanted to find the period and frequency of a person's heartbeat, okay, which is important, we start by looking at the pattern, and we see it's a repetitive pattern. We start here. Notice that we start at 0 because that's our starting time, and then we go 1 cycle, 2 cycles, 3 cycles, 4, 5, 6, 7, and 8. You can count as many cycles as you want. The more you count, the more accurate you'll be, but it becomes cumbersome if you have too many cycles to count. So again, count as many as is practical. Okay, once we have the number of cycles, we then want to look at what time did we start our study and at what time did we end our study. So you can see the starting time is around 1.16 seconds. The ending time is about 8.04 seconds. So we subtract those to get our delta t, how much time has elapsed during our measurements. To get our period, we take that number, 6.88, and we divide by our 8 cycles, and you see we get an answer of 0.86 seconds. To get the frequency, we can do the reciprocal. We can do 8 on top, 6.88 on the bottom, and we get 1.16 hertz. Remember, hertz means cycles per second. In the medical field, a lot of times they'll multiply that number for frequency by 60, and that will give you how many beats there are, how many cycles there are, not per second, but per minute. So you should be flexible enough to switch back and forth between cycles per second and cycles per minute. Obviously, there's always going to be more cycles per minute than there are cycles per second. When we look at a hummingbird and we see them flapping their wings, okay, they do this at a really high frequency, and believe it or not, it's as high as 70 hertz. 70 cycles, 70 flaps every second. So if we wanted to find the period, we can just do the reciprocal of that, and that'll tell us how much time it takes for one flap of the wing. As I was telling you, we're going to be getting into sound and light, and with sound, we're oftentimes going to be looking at music. So if you look at these guitar strings, as the person plucks them, you'll see that they are vibrating, and the frequency they vibrate will determine which sound they're going to produce. So if they produce the letter at the note A, that's usually 440 hertz. Each note has its own frequency, number of times that it oscillates per second. Again, if you wanted to find the period of oscillation, you would do the reciprocal of the frequency and find that it takes a really short amount of time for each of these oscillations. So I hope you guys see a little preview that sound waves are going to look just like the curves we were looking at just a few minutes ago. Finally, in a couple days, we're going to be working on a lab with pendulums, and I just wanted to give you a little preview. So just like we saw Anthony swinging back and forth down in the gym, here is a baseball swinging back and forth in front of a pocket lab, and it's going to measure how far the baseball is from the pocket lab. You can see it's going to go far, close, far, close, far, close, and it's just going to repeat that pattern. So if we wanted to find the frequency, what we would do is we would start here, go through one complete cycle. We got to come back right to where we started, heading in the same direction. So don't stop halfway, don't stop here. Go all the way through a cycle, go through another cycle, go through another cycle. Again, the more cycles you count, the more accurate you will be. And then you use our formulas that we talked about before to get frequency and period of the pendulum. Again, we just trace down to get our time. We count our cycles. Again, start counting at 0. There's 1 cycle, 2 cycles, 3, 4, and 5. So hopefully you guys have no problem using our 2 formulas for today. Frequency and period. And then don't forget, the relationship between them is they are reciprocals, and you could do it in either direction. All right, so that's it for today. Hopefully these terms are familiar. We looked at them with circular motion, and hopefully they are easy to work with. Get used to using these types of curves. We'll be looking at them throughout this entire unit.